Hello students, it's Professor Pi coming to you from the Tsunami Studios here at Pelican Bay State Prison. We're going to be working on fractions today, but before we get started, I want to remind you and to review the importance of having your multiplication tables memorized. Now, what numbers do you really need to know? You need to know 2, your 2s through 9s. Why don't you need 1s? Because 1 by any number is that number. Why don't you need 10s? Because 10 times any number, you just add a 0 onto the end of that number. But all the numbers that fall in here, you need to know in your sleep. You need to know them backwards and forwards. Just these numbers. And only certain numbers show up in our tables. 4, 6, 8, 10, 12, 14, 16, 18. Does 16 show up somewhere else in our tables? You should know immediately, yes it does. Where 4 and 4 meet is 16. Does 12 show up anywhere else in our tables? Sure it does. 3 times 4 is 12. Certain numbers show up often in our tables, and those are the numbers that you need to remember particularly. But all these numbers, you need to know instantly. So if you see a 27 and a 9, the missing number is 3. They're all in families or groups. 5s are very simple. 10, 20, 25, 30, 35, 40, 45. 4s, 20, 24, 28, 32, 36. So if you see a 32, you think 8 and 4. 24 shows up many times. 8 and 3, 6 and 4 is 24. Anyway, my point is, you need to be able to fill this table out in 2 minutes or less. If you can do it in 2 minutes or less, then you've got it memorized. And until you get it memorized, you won't be able to move on in math with any kind of speed. And speed is what it's all about. Because speed is a sign of fluency. And what we're working on here is mathematical fluency. Fluency. Fluent. If you're fluent in a language, you speak it quickly. That's the sign of fluency. Why do I speak English quickly? Because I'm fluent. I don't have to think about what my next word is going to be. It comes quickly. So math fluency, your math problems come quickly. You don't have to think about what you're doing next. It just comes. But this only happens with practice. So what we're doing here is practicing our math fluency. That's really the job that we're doing. We're going to get back into the book now, and we're using the number power series. The current version has a purple cover. This used to be called number power 2. Now it's called fractions, decimals, and percents. And we're working in fractions, which is the first of the 3 sections of the book. The book's divided into 3 parts: fractions, decimals, and percents, which are all related to each other. And I just want to remind you of how that works. 3/4 equals a percentage and a decimal. This is the fraction. A percent is a part of 100, and a decimal has a decimal point. So what percent is 3/4 equal to? 3/4 is equal to 75%. And how can we prove that? We're getting a little bit ahead of ourselves, but that's okay. We'll get back to this later when we get into percents. Percent means parts of 100. So 3 out of 4 is equal to how many parts out of 100? We can use our fractions. 3/4 equals how many hundredths? Well, we've learned earlier that whatever we multiply the denominator by, we're going to multiply the numerator by. So what do we multiply 4 by to get 100? 25. We'll do the same to the numerator. So 3/4 equals 75 out of 100, and any number out of 100 is percents. Now, to move from a percent to a decimal, we simply take the decimal point and move it over 2 positions. So 75% equals 0.75. We'll be getting into decimals and percents later. We're still working on fractions. And today we're going to be working on word problems for the first time. So Ms. Taylor is here to help us work through the word problems on page 12 of the book. So if you've got the book, open it up to page 12. Page 12 are the first word problems in our book. Thank you for joining us, Ms. Taylor. Come on up.
Hello, Professor Pi.
Good to see you today. So, would you please read the directions on page 12, and then we're going to work a few of these word problems.
All right. The writing fractions?
Yeah.
Writing fractions. Since there are 3 feet in 1 yard, 1 foot is 1/3 of a yard. 2 feet make up 2/3 of a yard. Write fractions for each part described below.
So, in each of these problems, we're going to have a whole and a part. Can you write up the problem, the question for number 2?
Number 2.
So, what is the question?
47 cents is what fraction of a dollar?
Okay, what's the whole? We're going to have a part and a whole. So, the whole is...
Oh. A dollar?
It is a dollar. And how many cents are in a dollar?
A lot. 100?
100 is correct. So, a dollar is our whole. 100 is our whole. And how many parts do we have in the question?
47.
That's right. So, 47 cents is what fraction of a dollar? 47 cents is 47 100ths of a dollar.
Okay.
So the part is 47 and the whole is 100. Can we reduce 47 100ths?
No.
I don't think we can. That's
No.
as simple as it's going to get. Very nice. I'm going to give you the pen back.
All right.
And we're going to do problem number 5 next.
Okay, so number 5 is 7 months, right? Or 7 months
Yep.
is what fraction of a year?
Right. So the question is 7 months is what fraction of a year, or 7 months is what part of a year. Fractions are parts of. So what would the whole be in this problem? How many is a whole year?
365 days?
But are we doing days?
No, months.
So how many months in a year?
12.
That's right. So I'm going to use the pen and write down our whole is on the bottom is 12. And our part is
Okay,
what?
7.
Is 7. So 7 months is what part
Oh, sorry.
or what fraction of a year? So 7 months is 7/12 of a year. Can we reduce 7/12?
No.
I don't think we can.
7 don't go into 12?
7 does not go into 12. You're right.
Okay.
There's no number that we can divide both of these by.
Okay.
So that's our reduced fraction. We'll do one more of these word problems. How about number 8? Oh no, 6.
6?
Let's do 6.
Okay. So number 6, 8 cents.
Okay. 8 cents is what fraction of a quarter or what part of a quarter. Do you want to try writing up the whole and the part?
I can try. So I'm gonna do. So we're gonna. The whole would be the quarter, correct?
That's
so
right.
It would be. Right.
Very good. 25.
Over 8.
That's right. The whole is 25 because a quarter is 25 cents, and 8 cents is 8/25 of a quarter. That's the part of a quarter that 8 cents is. Perfect. Can we reduce it?
No.
No, there's no number we can divide both 8 and 25 by. How about one more?
Okay.
Okay? I'd like number 8. Let's do number 8.
Okay, you want me to write it out?
Sure.
Okay. Number 8. There are 2,000 pounds in a ton. This is a good one. What fraction of a ton?
Very good. Okay. So there's 2,000 pounds in a ton. 1,351 pounds is what fraction of a ton? So what is our part and what's our whole?
Alright, this one's a little bit. Okay. There are 2,000 pounds in a ton. 1,351 pounds is what fraction of a ton?
So the total, the whole.
Yeah, it would be 2,000.
That's right. That's right.
Okay. It's trickier when the word problem becomes bigger. Right?
Yeah. We're translating this into math.
Okay.
2,000 pounds in a ton, okay? And 1,351 pounds is what part of a ton or what fraction of a ton?
So would would that be the top number?
That is our part.
Okay,
Yeah.
so 1,351.
And I'm just going to guess that this is not reducible. I can't imagine that it is.
If you ask me, I just have to tell you I don't know.
I don't know either. But a calculator, I might try dividing this number by that number or different things. But this question brings up an important topic that is up a lot in math, which is measurement, weights. Do you have your weights memorized for how much? Okay, a ton equals how many pounds?
Was that the one we just did?
Just the one we just did is 2,000.
Trying to throw me off.
And LBS, or LB, is an abbreviation for pound. Do you know how many ounces? OZ is the abbreviation for ounces. How many ounces are in a pound?
16.
That's right, 16 ounces in a pound. Now, do we have any lower? No, we don't have any lower weights in the standard system. This is called standard. These weights are used in America and England and maybe Australia. But the rest of the world uses a system called metric. And metric makes much more sense because everything is a system of 10. Instead of 16 to 1 or 2,000 to 1, everything is 10 to 1 or 100 to 1 or 1,000 to 1. So, in the metric system, a kilogram is 1,000 grams. A kilometer equals how many meters? Take a guess.
Really? 1,000?
That's right. So kilo means 1,000.
Okay.
A kilogram is 1,000 grams. A kilometer or a kilometer
So
is
just
1,000 meters.
meters.
That's right.
Okay.
So that's just a little snapshot of weights and measurements that'll be coming further on in the book. Anyway, hope you all enjoyed our introduction to word problems. This was about writing fractions, and it's on page 12 of the Number Power book. If you've got the book or a pamphlet with the problems on it, finish up the rest of the problems and send them in, or check your answers at the back of the book. So, from Professor Pi and Miss Taylor, bye. Hello students, we're continuing our writing fractions lesson, and we've got Miss Tiffany, our production coordinator here at Tsunami Studios, is going to be helping us out with these problems. We've moved forward to page 17. So we're on page 17. Oh, this pen is not working well.
Want to switch?
Yeah, let me use that one. Page 17. We're on page 17 in the Number Power book, and Miss Tiffany's going to write problem number 7 up on the board.
Of a foot, we got 1 foot equals 12 inches.
Very good. So the question is, 8 inches is what fraction of a foot, or 8 inches is what part of a foot. So we've got a part and a whole. What's our whole going to be?
It's going to be white whole like 12 over 12, which would be 1 over
Well,
1.
the whole is 12, so the denominator is 12. That's the bottom number. We want to know what part of 12 8 inches is. So 8 inches is 8/12 of 1 foot, which is correct. Now, because you've got your multiplication tables memorized, you know that both 8 and 12 can be divided by the same number.
Wait, 2/3, there we go.
And what number did you divide them both by?
4.
4. You could have divided them each by 2, but then you would have had to divide them by 2 again, because if you divided 8 by 2, you'd get 4, and if you divided 12 by 2, you'd get 6, and 4 over 6 can be reduced again to 2 over 3. So 4 is the largest number that we can divide both 8 and 12 by, and that's what you need your multiplication tables for. Very good, Miss Tiffany, thank you. We'll try another problem or two from page 17. How about number 11?
So 10 ounces is what fraction of a pound, and 1 pound equals 16 ounces.
Okay, so our whole is going to be what number?
16.
That's right. And what part are we looking for?
10.
10. So 10/16 is what fraction of a pound 10 ounces is. We can divide them both by 2, and we get 5/8. 5/8 is our final answer because we cannot reduce that anymore. Very nice.
Okay. That was easy.
Okay, let's see if we can find one a little more challenging.
Give her a hard one.
How about number 17? That's a lot of writing. You think
That's cool. I can write this
you
one.
can write all that out?
So we're just gonna write really small. Sheila has to type a 36-page report when she took a girl, you be taking a coffee break or a coffee break. She had already typed 20, let's do pages here, pages of the report. What fraction of the whole report, oops, that's me, has she typed?
So, like every other problem on this page, we're going to have a whole and a part. So what's the whole of this problem? The whole report is how many pages?
36 pages.
Okay, and what part has she typed?
20.
Yes, so 20/36. Can we reduce 20/36?
Yes.
What can we divide both of those by?
I'm going off 4 off the top of my
4 is a good one to start with.
Then we're going to do 5, and I think it's 40, so it's going to be 9.
Very good. Now I've got a question for you. It's not on the paper, but what part or what fraction of the paper does she still have to type?
So if you have 16 over 36, then you could divide, well, if she's got 4, divide that by 4 over 4. That's going to be, wait, 4 over, I could go further down. It's 4, that's going to be 9, 4. Oh yeah, dummy.
That is
You
it.
could've just done that.
4/9. Now take a look. 5/9 plus 4/9 equals how much?
9 9.
9/9. That's the whole. 9 over 9 is 1. So the part she's already typed is 5/9. The part she needs to type is 4/9. When she's done both of them, you add them up together, you get 9 out of 9. It's the whole. That's the
Man,
one.
I could have done it a lot easier.
Miss Tiffany, thank you so much. And thank you especially for being our production manager here at Tsunami Studios.
Aw,
Excellent work.
thanks.
So, from Professor Pi and Miss Tiffany, happy fractions to you.